Welcome back, everybody. Mr. Vidich here. Today we're starting a new unit on polynomials, and let's just jump right into it with a bit of a review. So in algebra, a letter that represents one or more numbers is called a variable, and we've seen a few of those already, such as x, y, z, or whatever it may be. And then we have expressions like 2a minus b plus 4 or 5 over x plus 3 are called algebraic expressions. And the difference between expressions and equations, even though they look similar sometimes, is that equations have obviously an equal sign. Okay, so if I were to write 2x plus 3, that would be an expression. But if I were to write 2x plus 3 equals 10, that would be an equation. So a bit of a terminology here to warm us up here. So a monomial is a number or a variable, or, this is important now, or the product of numbers and variables. Okay, so let's look at some of the examples here. So 6, that's a monomial. X, that's a monomial. 6x is also monomial. Okay, so it doesn't matter how many things you're multiplying. It would be a monomial unless you see plus or minus signs. Okay, so all of these are monomials. Okay, the important thing here is that the exponent on any of the variables must be a positive integer. So make sure you highlight that. That's a real important thing. So if you have x to the negative 1, that is not a polynomial or a monomial because of the negative exponent. Or same thing like x to the power of 0.3, that is not going to cut it. Okay, the number that multiplies the variable is the numerical coefficient, and you've heard me use that word before. In this case, 0.25 would be the coefficient, negative 1/2 would be the coefficient, 6 would be the coefficient, and this 6 here would not be a coefficient because it's just by itself. You need to have a variable in front of it. Okay, so therefore a polynomial is a monomial or a sum or difference of monomials. Okay, so a polynomial is a monomial or sum or difference of monomials. Okay, so if you have more than one monomial, you get what's called a polynomial. So in this case, all of these are called polynomials, but some of them have more than one term. And again, the important thing here with the terms is that they're separated by plus and minus signs. That's really important. Okay, so let's look at some of the examples down here. Okay, a polynomial with one term, we already looked at it, is a monomial. So example 4x is a monomial. A binomial would have two terms, and again, x plus 4, okay, that is two terms because they're separated by a plus or a minus sign. In this case, a plus sign. A trinomial, okay, the word tri, it means three things. So trinomial has three terms, so x squared plus x plus 4. All right, if you have 4 or more terms, we just call it a polynomial. Okay, I'll do a few of these. Consider the following algebraic expressions. In each case, state whether the expression represents a polynomial or not. Okay, so this first one is a polynomial. Okay, everything's okay. I have my variables, my coefficient. I have two terms. This would be a binomial. Here I have a problem because the exponent is 1/2, and remember our exponents have to be integers. This one is okay. Okay, that's a root 7, but that's okay because that's the coefficient. As long as you don't have any roots in the exponents, you're fine. Here this is almost okay, except there's a problem here. That's no good. Okay, the 0.2 is no good. And then finally, this is no good either because that 7a, if you were to bring it up to the top, would have a negative 1 exponent. And again, they have to be positive integers. Positive integers. Okay. All right. Let's do a couple down here. So complete the following table. Let me get a better pen here. I have to identify the number of variables, the number of terms, and whether and the name of the polynomial. Okay, so here I'm just going to jump right into this. This is called a binomial. Okay, because it has two terms and it has three variables, x, y, and z. Here I have three variables, a, b, and c. Three terms, so trinomial. Here I have three terms again, so trinomial. I'm just going to write tri, but I have only one variable, and that's x. Here I have one term, so monomial, and I have one variable. Here I have 1, 2, 3, 4 terms, so 4, so polynomial, okay? And how many variables? We'll have an x and a y, so two variables. Okay, let's look at the degrees of a polynomial. This is important. A degree of any monomial, so any one term, is the sum of the exponents of its variables. So let's look at the variables here. There's only one variable and has the exponent 5, so the degree is 5. Here I have a, b, and c, so I'm going to add them all together. Remember, there's a 1 here, so 1 plus 3 plus 2, that's 6. So this has a degree of 6. Okay, what about the degree of the entire polynomial? Well, to figure that out, you look at the degree of the term with the highest degree. So find the term that has the highest degree. This one has 5, this one has 4, this one has 4. So I'm going to go with this one. And because that's 5, this whole thing has the degree of 5. If a polynomial has a term of degree 0, okay, such as this one here, right, x to the 0 is just 1. So that would be a constant. So anytime you don't see a variable, you can say that's the constant. So in this case, the constant is -2. Okay. All right. Let me do this last example here. So give an example of a binomial of degree 1 in one variable. So a binomial of a degree 1. So I can just go x plus 3. There's one variable, one degree. I'm good to go. Trinomial in two variables with a constant term. So x plus y plus 3. Okay, we're good to go there. All right, a monomial of degree 6 with a numerical coefficient of 9. So 9 x to the 6, or I can write 9 x to the 3, y to the 3, any combination of that. Okay, a binomial of degree 8 with each term containing two variables. Okay, so each term containing two variables. So I'm just going to go x and y plus p and q, and degree 8. So as long as one of them has a degree of 8, I'm good to go. So I can make this 5 and a 3, and I'm okay. Okay, let's move on. A couple more definitions here. So we can arrange the polynomials in ascending or descending order. And the way we do that is we'd look at the powers of the variables. So in this case here, okay, we can write the polynomial in descending order. So we would write 4x cubed plus 6x squared over 5, and then we have plus 2x minus 7. Okay, and again, so the key thing is the degree on the term. In this case, 3 is the biggest degree. The leading coefficient is the number on the term with the highest degree. So in this case 4. Okay, so in this case the leading coefficient is 4, and the constant is -7. Again, the constant is the term without a variable. State the numerical coefficient of the term x squared. Okay, it's not just 6, it's 6 over 5. So be careful if you have a fraction. All right, we're going to skip the algebra tiles. I might show you that in class. So let me get to the next section here. Okay, adding and addition and subtraction of polynomials. Okay, so let's do a few examples. In order to add or subtract terms, we need to collect like terms. And what that means is if you have different variables in your terms, those are, apples and oranges. You cannot add or subtract those. So if I go 5 5 oranges plus 6 apples. Okay, I can't get 11 of what, so I can't do that. But I could go 6 apples plus 3 apples. Well, that's no problem. That gives me 9 apples. Okay, so you have to check that your terms are like terms. Okay, let's do example. The first one here, and what might help you if you circle or underline your like terms. So I have some A's here, apples. Okay, some apples here. All right, I have some B's here, bananas, and bananas here. Okay, and I have some cucumbers here and here. Okay, so let's do the bananas first, or the apples first. So 3 apples minus 3 apples. Well, guess what? I have no more apples, so those get crossed out. I start off with -4 bananas. I add 3 bananas. Okay, and that's going to give me -1 banana. Okay, and then I have 1 cucumber here. I lose 5 cucumbers, so -4 cucumbers. Okay, subtraction. You have to be careful with subtraction, because when you're subtracting all the things in the brackets, and you have to flip the signs if you have negatives. So for example, 4x squared, okay, they're already lined up for us. You can line them up like this to make it easier. So 4 minus 2, I have 2x squareds. Okay, those can be my apples. I have -9x's. I subtract -3, so I'm really adding 3. So I have -6x. 6 minus -1, again, that means 6 plus 1, so plus 7. Okay, just to show you this is kind of what it looks like if you have 6 minus -1. Well, that's really 6 plus 1, and that's how I got 7. Okay, let's do 2 more examples and then we're done. So I have 4 x's and I have -x here. So I have 4, I lose 1, I have 3 x's. Okay, now let's go on to the x squareds. You might want to do a little zigzaggy there for those, because they're different. So -2x squareds. So I lose 2 of them, I lose 6 more, so I'm in the whole -8. And I'm going to put those up here because, again, I want them in descending order, with the term with the highest degree first. Okay, the leading coefficient in this case would be -8. Okay, I also have some constants. Okay, maybe I'll circle the constants. I have 3 and 5. They're both positive, so +8. Okay, so there's the constant. All right, last one here. You have to be really careful when you're doing this, because sometimes they look like they're like terms, but they're not. A squared b is not the same thing as ab squared. So I'm gonna give those a squiggly line here. So a squared b, well, where is that again? Right there, a squared b. So I have 1 here plus the 5. I have 6 a squared b. Okay, here I have ab squared. So I lose 1 ab squared, I lose 7 more. Let me give those a straight line, and I have -8 ab squares. Okay, notice how the variables are written in alphabetical order. Okay, and then finally I have some a cube b's, and there's no other a cube b's, so I'm just going to rewrite that term. And was that a positive? I can't see there. That would be, and I'm going to write it first again because it's the highest term. So a cube, 4a cubed b, and there's that one. Okay, see you guys next time.